Okay, so just to give you some context here, I had set up this project some time back when I was trying to learn the low-level intricacies of the things, which is linker script and how to read map files and how to write your own drivers and how to write table-driven state machines and a whole bunch of other things. So this project is there on GitHub. You can check that out. And so the point of this video is that I'm going to show you the linker script and the components or the keywords associated with linker script. So the very first keyword when you look at a linker script is entry. So entry is basically the entry point of your software, which is the reset handler, which I have described previously in many videos that the reset handler is the very first thing that get executed in our system. And then we have the memory keyword. So memory keyword is basically used to define multiple memory regions across the entire firmware. So we have the flash and SRAM in our case, and then flash starts at some address and the length is 256 KB. And similarly for SRAM, it starts at some address and the length is around 64 KB, not around exactly 64 KB. And if you see the flash, we have a keyword here, RX, and in front of SRAM, we have RWX. So RX stands for reading and executing or readable and executable region. And SRAM has RWX, which is readable, writable, and executable region. Okay. So this is pretty much about the memory, and then you can have different subsections of the memory. As you can see, I have commented of the bootloader part here. So you can have bootloader, or you can have some kind of like firmware version details where you want to store. So those memory addresses you can define here, or memory regions you can define here, so to say. And then this is just an end of stack pointer. So underscore e stack, and end of stack is basically the starting point of SRAM until the end of SRAM, which is origin of SRAM plus length of SRAM. Okay, and then we have the sections here. So sections are basically three different sections of our embedded C code, which is the text section, the data section, and the BSS section. So I'm going to explain one of it and what it does. So if you see sections, it has defined as .text section, and it will be placed in the flash memory. Okay, and the pointer here, if you see dot, we have initialized here as origin of flash. So dot is basically the address or the pointer, you can consider it like that. And then if we come down, so it will hold the text region and the RO data region, and then it will again update the pointer by aligning it to 4 bytes, and then it provides the end of text pointer. Okay, so this is pretty much about the notations. So similar stuff is followed in the data section, but there is one difference, which is SRAM at flash, which basically means that initially the all the variables, global variables which are initialized, will be in the flash region, but when the program is running, they will be accessed from the SRAM region. So in order to achieve that, we write inside our startup code. So if I can show you that inside our startup code, if you see, we write basically the copying mechanism from flash data to SRAM data. Okay, so this entire linker script is written by me, and it is not perfect, but it is a very good starting point to explain things to people, which is what I like to do. And okay, so this is the meaning of this particular notation. It is also called as virtual memory address and load memory as address. So it will be having a load memory address in flash and a virtual memory address in SRAM. Virtual memory address basically means the memory address which gets used when your program is executing. Okay, so now if we come to the BSS section, so we have again the pointer here, which is aligned to 4 bytes. We have the start of BSS section, which is pointing to this memory location, and it is holding all the data that is residing in the BSS section. And then we provide the NBSS pointer. Okay, so now you might ask, where do we use these pointers? So the answer is in the startup code in the reset handler. So if you see here, we calculate the data size from by using the address of n data and s data. So this is the amount of size that we need to copy from the flash. So if you see, we have for loop which is running till the data size and basically copying all the flash data to SRAM data. Okay, so generally this startup code is also, you might see that it is written in assembly language, but for the sake of understanding and for the sake of easier readability and easier explanation, I have written it in C language. Okay, so similar to that, we have again the BSS size, which is NBSS minus the start BSS. Okay, which again comes from the linker script. Okay, so now we zero out the BSS section, and according to the notations, the uninitialized global variables will go to the BSS section and will be zeroed out, and the initialized variables will go to the data section with whatever values they are initialized, and uh, the constant the const variables will go into the rodata region, which will reside in the flash. Okay, so that is why you cannot change them. So if I declare two variables here, uint8 score t, my init is equal to 90, let's say, and init underscore t, my uninit. Okay, and then we have const uint 8 underscore t, my const is equal to 99. Okay, so according to whatever we discussed so far, this particular will go to the data section. Okay, and this will go to the BSS and zeroed out, and then this will go to the RO region. Okay, so let's just give clean build. Okay, cool. So just for your information, what I have done is I have the .c files and I have written make files and used make system to basically compile all my software to make it cross compilable and stuff like that. But anyways, that is not the point. So let's just go ahead and see where this guy is. So you see my init, it resides in the data section as we have mentioned here, and then my uninit, this one should go to the BSS section, and you see here it is going to the BSS section, and it is even mentioning the address which is in the SRAM region, which I already told you. Let's check the my const. Okay, so you see my const is going to the RO data, which is a part of the flash. You see the address starts with 0 cross 80, but in the previous one, which was, I don't know, my init. Okay, it is going to the SRAM region, and same goes for the my uninit. So if I go again, you see all of them are starting from 200, but in the case of const, it is starting from 800 because we have mentioned that all the const or the all the RO data will be placed in the flash region. Flash region starts at 800. You know, it's very easy to make out a story out of it, and you will be easily able to understand it. And I hope that that gave you some clarity. You can use the same technique to experiment with your own setups, with your own controllers that you have. Go ahead, you know, use some internet help and write your own linker script, and you will be good to go. You will learn a lot of things in that process. Okay, I guess that is pretty much enough for this video. Let's see you someday later. Thank you for watching, supporting. I'm already near to 1000 followers now, which is a great achievement I never expected. Yeah, thanks a lot. Bye bye.